we'll get started. So I'm going to do these in a particular order. Let me get that load up here that I think will be easiest to understand. One of the things that may not notice right away until you've done a bunch of these is there's the problems that are plus plus are all of the same type. All right, and I want to do those first. Those are the easiest. So for example, number 1 is x squared plus 8x plus 16. They are all plus plus. And when I say plus, I'm referring to those there. All right, so you're looking for two numbers that multiply to 16 but add up to 8. And if you're not sure, you just make a list. You're like, all right, 1 and 16, 2 and 8, 3 doesn't go in, 4 and 4, and that's it. Do any of those add up to 8? The last ones, right? So it's x plus 4, x plus 4. All right, so let's look at 16 next. 16 is like number 1. It's a squared plus 7a plus 12. So again, it's the plus plus case. So you're looking for two numbers that multiply to 12 but add to positive 7.
One.
Say that again.
1.
They have to multiply to 12. So like 1 and 12, they multiply to 12. But they don't add up to 7. They add up to 13. Does 2 go into 12?
Yeah.
2 and 6. 2 plus 6 adds to 8. So it's not that. What's another number that goes into 12?
I would think 1.
We've already done 1.
Oh yeah, we've already, yeah,
So,
4.
So you go up, you increment by 1 each time. You know, you go up, okay, 1 to 2, then to 3, and so on. What is 3 plus 4?
7.
7. Good. So the answer here is a plus 3, a plus 4. Let me know when you get that down.
I got it.
Okay, now this is the whole point of the plus plus case. There's plus here, and the answers are plus and plus. Plus here, plus here, plus here, plus here. Okay. So these are all of what I call the same type. So let's look at 34 next. And I want you to see that it's the same type of problem. They're both positive. The letters, the letters can be different, but it's the same deal here. So it's your answers are going to be plus plus inside here. Okay, so now can you find two numbers that multiply to 10 but add up to positive 7?
2 and 5.
2 and 5. So it's m plus 2, m plus 5. And so like one strategy here is to do all the problems of the same type. And that's what we're doing here. That's how I'm helping you is helping you to identify, oh, these are all of the same type. Okay. So 37 is like 34. It's the plus plus case. 37 is the plus plus case. Can you tell me what 37 factors into, please?
Uh, 4 and 5.
X plus 4, X plus 5. Good. So I think that's the last one of that type that we're going to see. You ready for the second case?
Yeah.
Okay. So the second case, I call it case 2 or type 2, It's when you have a minus and a plus. All right, so we're going to look at problem 7 to start. Okay, do you see how this matches up? It's minus and then a plus.
Yeah.
Okay, now it's kind of similar to the last one. You go to the last number 20, and you need to find two numbers that multiply to 20, but now add to, this is where it's different, -9. Okay, -9. So if you start out, if you're like, well, it's 1 and 20, these add up to a positive number. Okay, so the other possibility though is, what if they were both negative? Is -1 times -20, does that multiply to 20?
Yeah.
It does. And then it adds up to a negative number. -2, -10, -4, -5. Do any of these add up to -9?
-4 and -5.
So your binomials here is x minus 4, x minus 5. So instead of them both being positive, they're both negative.
Okay.
Okay, so let's look at number 19 next. 19 is like 7. And make sure there weren't any before that. Oh, this is going by, oh, sorry, 10. Let's do 10. Whoops. Missed one here. Sorry, I'm trying to find my, there it is. All right. So again, do you see that this is a minus plus? Like we're talking about minus and then a plus.
Yeah.
Okay, and all the first grouping of problems we did were all plus plus. So and the order does matter, minus plus. So you're looking for factors of 7, and the only factors of 7 are 1 and 7. But that's when you have to remember, oh yeah, because it's minus plus, these are both negative, because that's the only way you can get a negative number.
Yeah.
So this becomes p minus 1, p minus 7. So whenever you have a negative or subtract plus or minus plus, the answers are both negative. So let's look at 19. I'd like you to try 19 on your own here and see what you come up with. It's just like 10, it's just like 7, just different numbers.
-6 and -2. The yeah, -6 and -2.
All right, sorry about that. I was muted. Yes, this is correct. Good. Very good. So can you, do you have that page in front of you, this worksheet, the 7.5 practice?
Yeah.
Can you scan down from 19 and tell me the next one that's in this minus plus category that you see?
I think it's 40.
It is 40. Yeah. So we're gonna do 40, and then 46 looks to be the same thing. So we're gonna do those two next. Is it uncomfortable to do the problems out of order?
Yeah, it's a little weird. She had it this big ass sheet in rows, and she said, "I'll just pick half a row."
Well, it's like most things in life. Like, I mean, like when you unload the dishwasher, like I like to take all the plates out first, and then I like to do all the, bowls next or something. Like I mean, that's how I am. I'm very structured, as you can imagine, but you probably have some of that own structure in you in some area of your life. But yeah, try this one out here. This is another minus plus. So your answers are going to be both subtractions inside parentheses.
It's -1 and -3.
D minus 1, D minus 3. Good. And if you could try 46 next, please. And then we'll move on to the last case.
-1 and -17.
Yes. All right. So just to kind of summarize here before we go back to do the rest of the problems, there's three cases. Case one is something of this form. It's let me it would be like x squared plus bx plus c, and it always becomes x plus something, x plus something. Then the second case, x squared minus bx plus c, always becomes x minus something, x minus something. And that's what we've done thus far. We've done all of those in this worksheet here. Is that do you think that's clear? As it can
Yeah.
be. Now, unfortunately, it doesn't get easier, but there's only one more case, case 3. But there's two ways it could be presented: x squared minus bx minus c, so basically minus minus, or x squared plus bx minus c. But these produce the same case. You get x minus a number, x plus a number. Now you don't have to remember you don't have to remember like the B's and the C's, but you do have to remember plus plus means plus plus, minus plus means minus minus, and then everything else is 1 minus and 1 plus, or 1 plus and 1 minus. What do you think of that? Or give me some feedback if you have anything.
Yeah, it kind of makes sense.
So I liken it to like, it's like, well, if it's not case 1, then it must be case 2. But if it's not case 2, then it must be case 3. You kind of go down the list and, all right, like picking out clothes, maybe, don't like that, don't like that. Oh, I like that, or that's the one. Whatever analogy you want to make. So let's look at number 4. All the rest of them are going to be that third case here. And this is where it gets trickier, because you're now looking at -3, okay? And there's two numbers that multiply to -3. So there's -1 and +3, but there's also, when you switch the signs, 1 and -3. Do you agree that both of these multiply to -3? One negative,
Yeah.
one positive, one positive, one negative. Now, but only one of these will add to -2. Which of these adds to -2?
1 and -3.
Yeah, so that's the one you use. B plus 1, B minus 3. And notice how there's 1 plus and 1 minus. So what I think's hard for students is that you have to make this comprehensive list, and you have to get your signs just right. All right, so let's look at another one here. Let's look at 13. I believe 13 is next. So now you look at -14. You look at that last number there. And so to get to -14, it could be -1 and 14, 1 and -14, -2 and 7, 2 and -7. but only one of these will add up to +5 this time, +5.
-2 and 7.
-2 and 7, good. So that becomes your answers, x minus 2, x plus 7. And I apologize if I've asked before, but if you're allowed to use a calculator, please have it out and use it for these next few exercises, because I want you to try to start factoring these on your own. 22 is actually just the reverse of what we just did, but I'll have you look at that. Look at 22 next. So see how there's a -14 again, so you can use this list. Double up on it. Can you tell me what this factors into, please?
-2 and -7.
So give me the binomials. What goes in parentheses?
X -2. Or, yeah. And S plus 7.
Okay. So before I agree to that, it looks like you chose the same ones, but this one's slightly different than the previous one.
Wait.
Even the dog knows it's wrong.
-7.
+2, -7.
So my dog's barking.
Well, the dog thinks your problem's wrong. So, all right, let's look at another one here. 25. And the dog's fine. It's no big deal. 25 here. All right, so this one's got a bit more to it, and I strongly recommend you make this list. Okay, you can guess and check, right? You can find the right combination, but if you make the full list, you will get it eventually. Depends on how good you are at guessing, but they've got to add to -6.
X -9 in parentheses and X plus 3.
Good, very good. Now, just kind of a little more information here is this foils back to the previous line. And I think we've done enough of these that you know that, but if you're ever unsure, you could always foil and go back to check. All right, so let's have you try 28. What kind of dog do you have?
It's like a little papillon.
Okay. Does it think he's a big dog, or she thinks she's a big dog?
Very tiny dog.
But they sometimes like take on the personality of like the opposite.
Yeah.
My cousin has an English Mastiff that's gigantic, and it sits in your lap because he thinks he's a little puppy, a little small dog. It's kind of hilarious when it's huge things trying to get in your seat. So this one, two numbers that multiply to -28 but add to -3. So give that a try, please, if you can.
X minus -7 and X plus 4.
Okay, is this what you have written?
Yeah.
Okay, fantastic. Fantastic. 31. 31's another one like this. So again, there's two cases, right? There's when it's minus minus, like you see in the last two problems, but there's also the one where it's minus plus. But again, give this one a try. Two numbers that multiply to minus 24, but add to minus 5.
X minus 8 and X plus 3.
Okay, very good. All right, let's see which ones have we not done. Looks like there's only one left, 43 to do, and then we'll move on to the other stuff here. I really think it's important to sort of pattern these and recognize, the type before you do it. That helps to get the right answer. So if you need to, you can put a 1 there, so you know it's minus 1. But yeah, give this one a try, please.
N minus 3 and N plus 2.
Yeah, perfect. Okay. So like a good exercise to do is to take, because you've got like other columns, I guess, on that sheet, would be not necessarily to like do them, but identify the types that we said, or the cases, and maybe just write out like plus plus, minus minus, minus plus, or something like that, just to see if you can recognize. And that's really very important when you're doing this on a test or a quiz. Okay, so I see a couple other pages. Do you want us to start with 4? Do you want us to go to the other page? What would be best for you here?
Let's go to 4.
Number 4. Right. All right, so it says f of x equals, and I'm going to just take a guess here that it's 50 times 0.74 to the power of x.
Yeah.
All right. Okay, that gives the number of bacteria after x days of starting the experiment. What is the growth rate as a percent? So there's two possibilities here. Growth is 1 plus r, and decay is 1 minus r. So I think you're instructing incorrectly, and this is a decay problem. I don't know why they're saying growth. Because the number inside parentheses is less than 1. It's a decay. Okay, so you have to decide if that number is bigger than 1 or less than 1. It's called A in most problems. And then you decide that tells you which of these equations to use. Okay, so since it's less than 1, use the decay equation 1 minus r, like this. And then you would solve for r. Any idea how to do that?
I think I forgot.
Okay. So one thing you can do here, you have a choice here. You can either move the number, the 0.74, or you can move the variable. Which kind of are you drawn to, moving the number or moving the variable?
Moving the variable.
Okay, so I agree. I like that because if you add r to both sides, you have now r plus 0.74 equals 1. And is it clear that there's really a plus 0.74 here? It's just not written. That's why there's a plus down front.
Yeah.
All right, great. Now you can undo the plus 0.74. You can subtract 0.74 from both sides. So r equals 1 minus 0.74. And this equals 0.26. So this is the growth decay. I'm sorry, this is not the growth decay. This is the decay rate. Decay rate. Like that. So that is the answer they're looking for. They do want you to convert it to a percent. So to convert it to a percent, you multiply by 100. And that would be 26%, like that.
Yeah.
Any questions on that or any follow-up for me that you need me to do?
No.
Okay. Do you normally get these kind of review sheets, or is this something just out of the ordinary?
It's kind of normal.
Okay. All right, so number 5 here. Totally different. I mean, it's kind of related, but it's really just, something else in that chapter, that unit, to graph. So to graph, you really want to make a table when you graph. All right. So they're giving you the X values, and then they're saying, put them into the equation here, to the given equation, and then get your Y value out of it. So we're not going to start at -1. -1's hard. We're not going to do that. We are going to start it at the 0 though. So Y equals 2 times 2 to the power of 0 plus 1. And as a reminder, your order of operations tells you that you will first do your exponents, then you will multiply, then you will add. So what is 2 to the power of 0?
1.
Yeah, anything to the power of 0 is always 1. Okay, so in your and I know there's not a lot of room here, but you'd almost want to rewrite it as Y equals 2 times 1 plus 1. So now you're up to the multiply step. 2 times 1, 2 plus 1 is 3. Okay, so will you try the next two? Tell me what you come up with. Make sure you follow that order of operations.
I got 5 and then 9.
That is correct. Good. Okay. Now the hardest one here is the negative 2 times 2 to the minus 1 plus 1. So you need a reminder. You're like, what is 2 to the minus 1? And what it is, let me actually just, yeah, actually I'll do it like this. 2 is really 2 over 1. And then the minus 1 power, it's a flip. It's a flip inside the parentheses. So you flip and it's 1 over 2 to the power of 1. And whenever you have to the power of 1, you actually don't even need that. You can just not write it all together. So it becomes 1/2. So if you go back to the like worked out here, it's 2 times 1/2 plus 1.
It's 2.
Yes. Okay, now I like to graph. Next, I wouldn't wait a lot. I wouldn't wait time to graph here. So let me go grab this. Put that down here. Make this a little bigger. Yay! There it is. Okay. So first data point is -1, 2. -1, 2, like that. Next data point is 0, 3. Sorry, short-term memory isn't working today. And then 1, 5. And then 2, 8. Does that sound right?
Yeah.
Okay. Now this is not enough to graph this because these graphs all have a shape here where they have what's called a horizontal asymptote there. So I guess we do need to go and talk about that next. So let me snip that part in. So the equation of the asymptote, I'm gonna color code this. The equation of the asymptote is this number off to the right here, that +1. So it's y equals whatever that number is, which is 1. And then you typically show it as a like dashed line or dotted line, but I'm going to do it here like that. That's kind of your equation of your asymptote. See if I can change the color real quick here. Something like that. So the idea though is that the curve actually approaches it and then it rises. Like if you've flown on an airplane, it's kind of that where, it takes a while on the runway and then it takes off.
Yeah.
So that equation is always that number after the function. If there is no number, then it is 0. It's y equals 0. And that actually leads to the range, okay? The range is from the horizontal asymptote to infinity. Maybe you guys are probably using set builder though. You're probably just saying y greater than. Is that right?
Yeah.
Okay, sorry about that. You didn't want to be confusing. So y greater than 1. Now your domain, there's no restrictions. There's no bad stuff. How do you guys do that, say that when it's everything? You go all real numbers? Do you do something
Yeah.
else? Well, okay. All right. Great. So now I think that's everything for this one. Does that look right to you?
Yeah.
I think we've got it all. All right. We're doing great. Plenty of time to finish everything. So let's do this. Let's go to number 6. All right, so the length of a rectangle is 2x plus 5, and the width is 3x minus 1. So it's probably good to draw your favorite rectangle. And do you want the 2x plus 5 to be on the horizontal or the vertical?
The horizontal.
Okay, yeah. And then 3x minus 1 here. All right. So now the perimeter is going all the way around. So if it helps, you can label the other sides. You can say, okay, I need to label the top now as 2x plus 5 and the left side is 3x minus 1. So the perimeter is 2x plus 5 plus 3x minus 1 plus 2x plus 5 plus 3x minus 1. So can you combine like terms, add that up for us? Let me know what you come up with.
That's 10x plus 8.
That's right. 10x plus 8. Very good. Okay. So the area now, the area of a rectangle or really any parallelogram, parallelogram is base times height. We'll cover that a little bit next year. So your base, and it doesn't really matter because you're gonna multiply them by each other. Is 2x plus 5 times 3x minus 1. And you do have to multiply. You do have to FOIL. I think we were doing that in a couple lessons ago.
Yeah.
So will you FOIL this and tell me what you come up with?
Uh, 6x.
Excuse me.
6x squared
Okay.
minus 13x minus 5.
So 5 times 3x is positive 15x
Oh yeah.
minus 2x, and then yes, minus 5. I agree.
Positive 13.
Yeah. 6x squared plus 13x minus 5. Good. Very good. Now, the small thing here is they probably want units. The perimeter is feet and the area is feet squared. It's a small thing, but like if this were a test, you might get dinged if you don't give that full answer there.
Yeah.
All right, so on to 12 and 13. Does that sound right to you?
Yeah.
Okay. So 12 is a money problem. You need the compounding equation. So here we go. So you got to have the equation. There's no way to do it without this. The future amount is the amount that you started with times 1 plus your interest rate divided by the number of compounding periods to the power of number of compounding periods times the number of of years. So there's several variables that you have to know to answer this, and they're all given. These are all given in this problem. So I'd like you to tell me any of them that you see, kind of, process of elimination, get it down if there's any you're not sure about. P is the starting amount, R is the interest rate as a decimal, N is the compounding periods, and T is the number of years.
Yeah. So P is 1,700.
Okay.
R is 5.3%.
So yes, but it's got to go to a decimal.
Yeah. So could be 0.053.
Good. And then your N.
That is 4.
Good. And T.
5.
Good. So once you get those down, the only kind of critical path here is if you are not able to get this into the calculator correctly. I don't know if we spent any time talking about calculator stuff, but if you got one handy, go ahead and grab it and let's have you calculate this. Or if you're not sure, you can go to that Desmos Scientific. It's pretty solid for that.
All right. I got 2,211.
0.98.
0.97.
Yeah, and the cents matter. I mean, if some point it becomes important.
I finally saw that movie, Office Space.
Oh, you did. Oh, you did. Okay. I mean, I don't know if it's a great movie. It's kind of a, it's an older one, but few famous actors in there.
Yeah.
Did you get the whole jump to conclusions, Matt? Did you see that? Do you remember that?
No.
Okay. All right.
I saw like half of it.
All
I
right.
fell asleep.
Yeah. Have you ever seen The Office? The TV show The Office?
Yeah.
So the Office Space is kind of like in my mind, my lifetime is a precursor to The Office, and The Office is nuts and crazy, but you can't do that anymore. But it's if you ever get in, maybe ask your parents what it's like to work in an office. It is some of that. It's unbelievable. Okay, let's work through this real quick here. So the value of K is the natural log of 1/2 divided by 8, or T.
Okay.
So you have to get that number. You're probably going to want to like round to, I'll say 4 decimal places. We're shortcutting this one a little bit just because I want to make sure we get through it, but minus 0.0866. And then your function here, your function is A of T equals the initial amount. Okay, so you had 40 E to the minus 0.0866 T. That's kind of that first box, first line that they're looking for. And then you put in 40 for T. 50e to the minus 0.0866 times 40. All right, and that becomes 1.57. 1.57. And probably good to put the, I guess, the pounds in there. All right, so we're gonna stop recording there.